Okay, so tomorrow's quiz, guys. 8 questions, a couple multiple choice. If you're going on Transfig, you just make it up when you get back. I posted the answers. If you go to the assignment itself on Canvas, the answers all worked out or posted so you guys can see those. But I just want to work through some specific ones, make sure that we understand what questions are asking and how to answer them. What is the difference between stuff we did in 7.4 and stuff we did in 7.5? Like, this question looks exactly like something we saw in 7.5. What is this missing? Oh, say it again. They do have a common denominator. Good. Do these have equal signs? No. Are we solving these equations? No. If it doesn't have an equal sign, guys, you're not solving to get x equals. If there's no equals, all you're doing is combining. It says find the sum or difference. It just means add them or subtract them. But you're not going to get x equals. So in a case for number 2 and for number 3, like Gigi just said, oh, wait a second. They both have common denominators. So that means if the denominator is the same, you can just rewrite the numerator over the same denominator. So in number 2, I have 9x squared, correct? And then I can rewrite the numerators as x minus 3. Is there anything that I can cancel out? No. Why can I not cancel out? Because the x is what? It's connected to that 3. You cannot say that, oh, I can cross out the 3 and the 9.
Why not?
All right, so we're simplified. We cannot do anything else here. If it asks you for domain restrictions, I don't know if it will or not, what can x not be? Right, because you would say 9x squared cannot be 0, divide both sides by 9, x squared cannot be 0, take the square root, x cannot be 0. If they ask for the domain, guys, make sure you set the denominator not equal to 0. So look at number 3. Same denominator, so I just rewrite the denominator one time, and I combine the numerators. 7 minus 3x. Can I cancel anything? No. Is any parenthesis on top and bottom exactly the same? No. So that's it. That's simplified. In this case, what can x not be? Positive 2. Good. Questions? Now, these least common multiple questions, I'm not super pumped about. I think they can be a tad confusing at times. If there is one on the quiz, this is how I want you guys to do it. All right, let's talk about this. 3x squared. Can you simplify 3x squared at all? No. So let's take 6x minus 18. Can you factor that at all?
Yeah.
What? 6 and what does this become? X minus 3. So to find the least common multiple, you have to have everything that's different. Everything that's different are the pieces you want. So I'm going to write down an x squared. And what else am I going to write down? An x minus 3. Now for number-wise, what is the least common multiple between 3 and 6? 6, right? The least common multiple is the multiple that they have in common, that's the smallest. 3 times 1 is 3, 3 times 2 is 6, 6 times 1. For numbers, least common multiple, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, right? So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. The least common multiple is the number, the smallest one that they have in common at that point, so it would be 6. Another common multiple is 12, but it's not the smallest that they have in common. I think these are a little easier when you have something like number 7. Let's factor number 7. What can this factor into? What times what? It's going to give me a negative 10 when I multiply?
Negative 5 and 2.
Okay, so x minus 5 and x what? Plus 2. And then over here we have x plus 2. So your least common multiple is all the stuff that is different. What do they both have? They both have an x plus 2, right? And then what else? X minus 5. You guys are perfectly fine with this if you're making, if you went like this. And I said to you, add those together. Every single person in here could say, oh, I can get a common denominator. That's all you're doing. So if it helps you to write it like a fraction and then say, what would my the common denominator be? That's probably the easiest way to attack a problem like that. I could do more of those in a minute if you want me to. But let's go through here. It says, find the sum or difference. I don't know why this is here. Let's take that equal sign off. Because if we're just finding the sum or difference, we're not solving it. So first thing I have to do is say, wait a second, I need a common denominator, correct? What's my common denominator between x plus 4 and x minus 3? X plus 4 and x minus 3, correct? So now we look at each fraction individually. What does the first one have and what is it missing? What does the first fraction have? What is it missing? The x minus 3. What you multiply in the bottom, you multiply where? To the top. My second fraction has the x minus 3. What's it missing? Perfect. X plus 4. So what you multiply to the bottom, you do to the top. I think this is a really good idea to write it out just like I am. I'm going to rewrite this whole numerator as 6 times x minus 3 minus 5x times x plus 4. We're not getting rid of denominators, guys. There's no equal sign, so we're not solving this. We're just simplifying. So now I'm going to distribute. I have 6x minus 18. When I distribute, guys, this becomes minus 5x squared. And then negative 5 and 4 is negative 20x, right? Okay. So negative 5x squared. What does this become? Negative 14x. Agreed? Okay, and then what? Minus 18. Can we factor this? What can we take out, first of all? A negative 1, right? So this becomes 5x squared plus 14x plus 18. All right, what's 5 times 18? Times 5, 48, 90. Are there factors of 90 that'll multiply to give me 90 but add to give me 14? So 1 and 90, 2 and 45, 3 and what, 30, 4 and 15, 5 and 18, 6. Six and what? 6 and 15. So what is 4? Does 90 and 4, does 4 go into 90? No. Come on, pay attention. Let's go. Any of these combinations, guys. 9 and 10. 3 and 30. Any of these combinations going to give me a 14? No. So you're fine. You can leave it as negative 5x squared if you want. Minus 14x minus 18. Or you can factor out the 1. And then you have the x plus 4 and x minus 3 in the bottom. But what I want you guys to see, when it does not have an equal sign, you're just combining the numerators. You're going to get a common denominator and get the numerators together. But you got to watch your signs. If it has an equal sign, then we get a common denominator, we drop the bottom, and we're good to go. All right, let's look at 12. First thing we need to do with our denominators is factor. Good. What are the factors of negative 18 that multiply to give me a negative 18 but add to give me a positive 7? Perfect. X plus 9, x minus 2. So our common denominator would be what? X plus 9 and x minus 2. Perfect. So my first fraction has both things, right? So I just rewrite it. My second fraction has the x plus 9. What is it missing? X minus 2. Very good. So, can I just cross off the x minus 2's now? No. You cannot, because that 6 times x minus 2 is attached to that positive with the 14. You have to distribute and then combine. So I have 14 plus 6x minus 12. What can I combine here? 14 and negative 12 gives me 6x plus 2 over x plus 9, x minus 2. Can I simplify the numerator a bit? Yeah, I could take this out, and this would be 3x plus 1 over x plus 9, x minus 2. Does that help me at all? No.
Would you take points off?
No, either one of these is fine. Either one of these is fine. The only time that you really have to do it is if when you do factor, then something cancels out. then you have to say, oh, wait, I can simplify this.
Top and bottom.
Has to be exactly the same on top and bottom. What can x not be? Negative 9 and positive 2. What happens when it is one of those two numbers? Your denominator becomes 0. All right? You guys good?
We have to have that. The x is not equal to.
It depends if it asks for restrictions. All right, these first two, we love these two kinds of problems. Why do we like 2 and 3? You can just cross multiply. Why can we just cross multiply? Because it's a fraction equals a fraction. So I'm going to cross multiply. I'm going to do it up here. So I have 4 times x minus 2 equals 6 times x plus 2. Now we distribute. So 4x minus 8 equals distribute 6x plus 12, right? Now what? X is to one side, numbers to the other. I'm going to subtract 6x, and I'm going to add 8. So when I do that, what's 4x minus 6x? Negative 2x, perfect. My 8's are going to cancel here, and so does my 6's. What is 12 plus 8? Equals 20. Awesome. So when I divide both sides by negative 2, what does x equal? Negative 10. Now, I'm good with that, guys. Now, we love these equal signs because then we can say, okay, good. I know for a fact I got it right or not. What do I have to do with that negative 10? I got to plug it in and just make sure what? That the denominator does not become 0. You can check it all the way through and make sure the left-hand side equals the right-hand side. But when I say negative 10 plus 2, not 0. When I say negative 10 minus 2, not 0. We're good. Yes, sir. No, you don't have, you get points off if you tell me that that's the correct answer, but then when you plug it back in, the denominator becomes 0. Because then it would be extraneous.
Would there be any of those questions?
Yeah.
Extraneous questions.
Mm-hmm.
Okay.
Let's look at here. We're going to cross multiply. So I have negative 3 times x minus 5 equals x plus 1 times x minus 5. So we're going to distribute negative 3x plus 15, and then I have to FOIL. X times x is x squared. X times negative 5 is negative 5x. 1 times x is plus x. 1 times negative 5 is negative 5. It's a quadratic, guys. Let's get everything to one side. I'm going to move everything to the right just because I want to keep my x squared positive. You could move everything to the left. That's fine. Just have to deal with the negative. So I'm going to add 3x and subtract 15. So add 3x and subtract 15. That leaves me with x squared minus 2x. Wait, we didn't combine here, did we? So this would be minus 4x. So this would be x squared negative 4x plus 3x gives me minus x, right? And then what's negative 15 and a negative 5? Minus 20 equals 0. Can you factor that? What times what gives me negative 20 when I multiply, but a negative 1 when I add? Minus 5 and plus 4. Good. So what are my two x values here? X equals positive 5 and negative 4. What do I have to do? Why do I have to check these? Watch what happens here, Jeremiah. When I plug in a 5 here, what's 5 plus 1? 6. We're good to go, right? What happens when I plug in 5 here? What's 5 minus 5? 0. So what does that tell me about x equals 5? Is that a valid solution? No, that's extraneous. If you guys circle that and tell me that's right, I'm taking points off because it's not. It makes your fraction undefined. When I plug in negative 4, am I good? Yes. So in this case, the only valid answer is negative 4. When you have a quadratic, especially, you need to check. Does it always happen where one cancels out and one doesn't? No. Sometimes both of them work, sometimes none of them work. You just always have to check that. All right, a couple more. Let's do 9. Let's do number 9. What is my common denominator going to be for number 9? X and x minus 3. I agree. So I'm going to have x times x minus 3. That's my common denominator. So I have to figure out what each fraction has and what it's missing. What does this first fraction have? X minus 2. It has the x minus 3. What's it missing? X. Okay, so I have x times x minus 2. My second fraction, the 3, what is it missing? Both. Missing everything. So x times x minus 2 equals, what's my third fraction missing? The x minus 2. So 2x times x minus 2. Once you get everything to have the same denominator, what can you do to the denominator? We'll cross it off. Ay, Jan Marie, what's going on here? Thank you, babe. So now we're going to do what? Distribute, right? X times x is x squared. X times negative 3 is negative 3x. Everybody with me? Plus, what's 3x times x? 3x squared. What's 3x times negative 3? Minus 9x. Equals, what's 2x times x? 2x squared. What's 2x times negative 3? Minus 6x. What do we have going on here? Is this a quadratic? How do you know it's a quadratic? Yeah.
The first one is that x squared minus 2x.
This is a 3. Because of this. I was looking at the top, not the bottom. So if he corrected me, thank you. All right, can we combine here? What's x squared plus 3x squared? 4x squared. What's a negative 3x and a negative 9x? Negative 12x equals 2x squared minus 6x. God bless. We're good so far? Okay, so let's move everything to one side. So I'm going to subtract 2x squared and add 6x. Subtract 2x squared and add 6x. So 4x squared minus 2x squared gives me 2x squared. Negative 12x plus 6 gives me negative 6x, correct? Equals what? Equals 0, okay. Some of you got here, and then you were like, now what do I do? We factor. What do they have in common? 2x. So if I take out the 2x, I'm left with x minus what? 3. So I do what with each piece? I said each piece equal to, there you go. So x equals 0 and x equals 3. I have to go back up here and do what? I have to plug in. Make sure that either x value, when I plug it in, does not make my denominator 0. So let's try 0. If I plug in 0 here, am I okay? What's 0 minus 3? Not 0. We're good. What happens when I plug in 0 there? My denominator is 0. So does x equal 0 work? No. What about 3? What about if I plug in 3 here? What's 3 minus 3? What's 3 minus 3? 0. So does x equal 3 work? Do either of my answers work? So what's your answer here for number 9? No solution. What? All right, I did. I messed this up. This should be a 2, not a 3. Think about this, though. I'll redo this whole problem and at the end of the video. But what would happen? I'm glad that this happened. What would happen? And this could possibly happen, guys. It could possibly happen that you work this all out, you get 2 answers, and then you plug them both back in and they don't work. What would your answer be? No solution. Don't automatically assume that you did something wrong. In this case, I did because I was not thinking. But don't automatically assume that you did something wrong, because that absolutely could be the case. Where you do everything right. You factor it, everything's pretty, and then all of a sudden it's like, wait a second, when I plugged this back in, it didn't work. All right? You guys understand what I'm saying? I'll redo 9 with x minus 2 instead of x minus 3. I may have worked out one of the versions of the quiz and this happened, and that's what I was thinking about this morning. So if it does come up on your version of the quiz, don't freak out. Does everybody understand? You got a little sneak peek that I wasn't planning on giving you. That's my bad. Yeah.
So we will have the question.
It's possible. Not saying, okay, now listen, not saying everybody's version will have a no solution. but the possibility is there. I gave you a sneak peek that I was not meaning to give you, so that's my bad. Yeah, yeah. All right, of 11 or 12, what do you guys want me to do? 11? Okay. And then I'll do some inverses, and then we'll be done. Common denominator. What's my common denominator going to be on 11 between x, 1, and x minus 4? X and x minus 4. Perfect. Remember, once we get the denominators to be the same, you don't have to deal with it anymore. So look at the first fraction, x. My denominator is just x. What is it missing? X minus 4. So I'm going to write 8 times x minus 4. My second, I have the whole number 3. What is it missing? Both the x and the x minus 4. Good. Then I have an equal sign. Then I have x plus 8. It has the x minus 4. What is it missing? Just the x. Everybody see what I just did there? Now, once we have this all set up, we just distribute and simplify. 8 times x is 8x. 8 times negative 4 is minus 32. Plus 3x times x is 3x squared. 3x and negative 4 is minus 12x. And then when I distribute here, I have x squared plus 8x. What kind of a problem do I have here again? A quadratic. Go ahead and simplify everything on the left-hand side first. So I have my 3x squared. What's 8x minus 12x? Negative 4x, good. Minus 32. And then how can I move 8x squared, 8x and x squared to the other side? Subtract x squared and subtract 8x. So 2x squared minus 12x minus 32 equals 0. When I factor this, what do you see immediately they all have in common? They all have a 2. So I have x squared minus 6x minus what? 16. Can I factor that? Factors of 16 that multiply to give me 16 but add to give me negative 6. Minus what? What's going to multiply? I have 1 and 16, 2 and 8, 4 and 4. So minus 8 and plus 2. So we said each piece equal to 0. So 2 equals 0. True? Ever? No. So what does x equal? Positive 8 and negative 2. What happens when I plug in 8? We okay? Can I plug an 8 in here? Can I plug an 8 in here? Okay. What happens when I plug in, what was it, negative 2? Can I plug in negative 2? And I don't get 0? So in this case, what happens? They both work. So is there a time when you can get a quadratic and you plug in both x values, they both work? Yes. Is there a time that you plug in both x values and neither of them work? Yes. Is there a time you plug in both x values and only one of them works? Yes. Okay, I want you guys to be aware of that. Everybody with me? All right, let's talk about inverse and then we'll be done. I'll do 40. I want to do 40 and 44. I'll make sure we do 44. With inverse, guys, remember, you have to have inverse notation on your answer. Don't leave it as y. I'm going to take a point or two off. You have to have, hey, Mrs. Meadows, this is the inverse. So let's talk about how to find the inverse. The first thing we do is replace f of x with what letter? Y. So y equals 5 over x minus 6. Now what do we do? The most important thing in solving to find the inverse is this first step, which is swap the x and the y. Very good. If you need to, remind yourself that y is what I'm trying to get by itself. I have to undo everything else. So in order to undo everything else, what's my first step? I'm going to add 6. Perfect. So I have x plus 6, put everything in parentheses if you need to, equals 5 over y. And then now what? Multiply both sides by? Okay, good. Thanks. So you have y times x plus 6 equals 5. Now remember, we're trying to get y by itself. Don't distribute or anything like that. I want to get y by itself, so what do? Divide both sides by x plus 6. So y equals 5 over x plus 6. Is that my final perfect answer? What's the last little thing I got to do? F negative 1 of x equals 5 over x plus 6. Make sure, guys, that negative 1 is like an exponent. It's little. Don't make it like a normal size negative 1. Questions? Say it one more time. Yes, you have to have that f negative 1 in order to get full credit. Now let's look at the last one. I have f of x. I'm going to change it to y. And then it's 1 over x to the 4th, right? Minus 7. Before we even start, guys, what kind of a number is 4? Is it even or odd? Even. Okay, we need to remember that. You'll see why in a second. So my first step, I'm going to say x equals 1 over y to the 4th minus 7. I'm trying to get 7 to go to the other side. I want y all by itself. So my first step is to do what? Say it again. Add 7, okay. So I have x plus 7 equals 1 over y to the 4th. Now what? I'm going to multiply both sides by y to the 4th. So I have y to the 4th times x plus 7 equals 1. Now what? Divide by x plus 7. All right, here's where we got to pay attention. I have y to the 4th equals 1 over x plus 7. How do you get rid of something squared? You take the square root. How do you get rid of something to the 3rd power? You take the cube root. How do you get rid of something to the 4th power? You take the 4th root. Now, guys, why am I making a big deal about this? First of all, if you're taking an even root, what goes in front of your answer? Plus or minus. If you take the square root, the 4th root, the 8th root, the 6th root, it has to have a plus or a minus. You can leave it just like that. But if you take an odd root, you don't need that. But an even root, write that down. Even root, have to put plus minus. Because it could be positive 4th root of 1 over x plus 7, or it could be negative 4th root of 1 over x plus 7. Anytime you take an even root, you have to have the plus or minus. You guys with me? All right, I'll do number 9 right now. I'll just sit over there and talk to myself. Okay, here's the correct number 9 without me making my silly mistake. So I have x minus 2 over x minus 3 plus 3 equals 2x over x. So plus 3 over 1 equals 2x over x. So our common denominator is going to be x times x minus 3. So my first fraction has the x minus 3. What is it missing? It's missing the x. My second fraction has nothing, so we have to multiply by everything. And then my third fraction has the x. We're missing the x minus 3. So when we write out our numerator, we have x times x minus 2 plus 3x times x minus 3 equals 2x times x minus 3. So now we'll distribute x squared minus 2x plus 3x squared. 3x negative 3 is going to give me minus 9x equals 2x squared minus 6x. So x squared and 3x squared is 4x squared Negative 2x and negative 9 is minus 11x equals 2x squared minus 6x. With our quadratic, we'll move everything to one side. So I'm going to subtract 2x squared and add 6x. So 4x squared minus 2x squared is 2x squared. Negative 11 and positive 6 is going to give me negative 5x equals 0. So what can we factor out here? We can take out an x. This leaves me with 2x minus 5 equals 0. So now set each piece equal to 0. X equals 0. And when I solve this, I get 2x equals 5, so x equals 5 over 2. So now let's check our answers and see what happens. If I have 0 as an answer, if I plug 0 in here, we're good to go. But if I plug 0 in here, we are not. So this is not a valid answer. 5 over 2, I can plug in 5 over 2 here. I can plug in 5 over 2 here, we're good to go. So this is a valid answer.